Hi. So for my Digital Electronics 2 lecture and laboratory subject, this is the final assessment, summative assessment 4. So the objective for this assessment is to create a big microcontroller based project wherein a coin acceptor and servo motor is being applied. So the application that I thought for this is a coin-operated vehicle barrier for contactless parking fee. So this is the barrier gate. So the servo motor is most commonly used for high technology devices in the industrial application like automation technology. It is a self-contained electrical device that rotates parts of a machine in high efficiency and great precision. The output shaft of this motor can be moved to a particular angle. Servo motors are mainly used in home electronics, toys, cars, and airplanes. A servo motor consists of three wires: the black wire connected to the ground, a white or yellow wire connected to the control unit, and a red wire to the power supply. The function of the servo motor is to receive a control signal that represents a desired output position of the servo shaft and apply power to its DC motor until its shaft turns to that position. It uses the position sensing device to figure out the rotational position of the shaft, so it knows which way the motor must turn to move the shaft to the instructed position. The shaft commonly does not rotate freely around, similar to a DC motor, however, rather than can just turn 200 degrees. In a barrier gate, the barrier gate works when the device drivers over the vehicle detector loop and relay is activated at the automatic barrier gate opens. The vehicle leaves and the exit vehicle detector loop signals the barrier gate to close. So this is the sample of the barrier gate. So here is where you insert the coin, and once you insert the coin, this barrier here will go up and down, and the only time that it will go down if there is a sensor here when your vehicle already passed the barrier. So now let us start on creating our application. So there, this select the device to the IC F1508. Click on the compiler, click next, project name, put your desired project name. You can name it whatever you want. Just wait for the application to load. Click on MCC, save the myconfig file. Here is the MCC. So first, let's change the package. This is the package that I have. It's because this is the IC that I have. So now let's check on the device resources and add PWM4 and timer 2. Here, let's change some settings for the timer 2, PWM4, and system module. Here for megahertz, this one for the PWM4. And for the timer 2, it is important to change post scalar to 1:1 and pre-scalar to 1:64. And also, I forgot this should be enabled. For the timer 2, this should be 16 milliseconds. There. And then, next is for the interrupt module. This is just the default settings. And now, clicking on the pin module, let's open pin manager and open ports 5 and 4, RA5 and RA4. RA4 is for the LED, so let's rename this LED. This is for the output of the LED. And the coin is for the input of the coin acceptor. So change the settings to this. Next, click on generate. Yes. as you can see here, generation complete. So here on the main C file, here is our code. So this is the code for the IC. So this code is from the microchip website. I just added the if and else statement. So if one coin is inserted, LED will turn on, and else LED is set low. So build successful. And then next, let me just change this to 30 to make the movement of the servo motor slower. So faster. So here I'm selecting the hex file and programming it to the IC, and programming complete. Now let's program our code to the IC itself. Let's open MPLAB XIPE application. Once it is open, let's change the power settings. Password is microchip. Change the power settings to 3.125 there, and change this to F1508 and connect. Wait for the application to connect to your Picket device and IC, and after this click on OK and click on browse to browse your hex file there, and program, and click on OK. Programming complete.
This is the circuit that I made for this summative assessment. So first, let's start on the connection of the power supplies. This yellow wire here and this white wire here is for the 5-volt power supply. This is the negative. This is for the negative. And this is for the positive. So this is the negative terminal. This is the positive terminal for the whole circuit. So as you can see, this negative wire is connected here, and this positive wire for the 5 volts is connected here. Next, for the 12 volt, let's look here. This wire here is from the 12 volt power supply, and it is connected alongside with the negative 5 volt here. And the positive terminal of the 12 volt power supply is connected to the positive of the coin acceptor. So now that we're done with the power supply, let's now look on the circuit connection of the rest of the circuit. Here at the coin acceptor, you can see this black wire here is for the ground, and of course it is also connected to the negative terminals. And this white wire here is connected to the second pin of the IC, this green wire here, because this green wire here is for the input of the pulse from the coin acceptor. Next, this VDD is the first pin connected to the positive terminal. This 20th pin is the VSS. It is connected, of course, to the negative terminal. Next, this 15th pin here is connected to the input of the servo. And the red wire in the servo is of course connected alongside with the positive terminal. And the brown wire in the servo is connected to the negative side of the whole circuit. So I think that's it. Oh no, I forgot. This third pin right here is connected, of course, to the LED, because we're required to add LED lighting for when a coin is inserted to the coin acceptor. So this third pin here is the output, so it is connected to the LED here, and there is a resistor, and this resistor at the negative side is connected at the negative side, and this resistor is connected then here again to the negative terminal. So there. So let's now check on the circuit if it works. So again, the application for this summative assessment is a coin-operated vehicle barrier for contactless parking fee. So imagine if you are to insert a coin in when you're entering the parking entrance. So this is the barrier, and it will only open if you insert a coin or the designated amount, and also the LED will turn on, so it means that you can go. And in a true 1, 2, 3 in real life, there would be a sensor that would make this servo motor go down for when the car already passed through the barrier gate. So for now, this is just a prototype of what a servo motor can be used for. So let's check. Let's insert a coin. There, as you can see, the LED turned on and the servo motor moved. So imagine this is the barrier. There. It worked.